start straight away waiting for people to show up. We also started. We get to 60 people. I'll start. Oh, we went down from 40 to 20. Maybe I won't wait for 60 then. Oh, no, that was a glitch. No, it's not a glitch. My gosh, this view count is crazy. I refresh it showed 52, and then it showed 30. All right, people aren't going to stick around if I don't program, I guess. So I better start. Now it's 52 stable. Okay, so we were here. What were we doing? We were drawing all the intersections. Let's see how that looks in terms of the drawn intersection. Oh, right. We were seeing some intersections created that didn't have a corresponding line segment like that one. And we assume that this is because we're making intersections that aren't valid, which means in the edge code we're making intersections. Okay, here we have a 50% chance of going through, deleting all the intersections and deleting the facing road. So that's slightly under 50% chance. Oh, we've just made it worse, it seems like. Where's my mouse cursor? There it is. Generating these two. Not generating that one. That should be X1, Y1. Aha. X1, Y1. We're working on the road network for the city. So what we're looking at. We're ignoring the city in the background. Yeah, okay, so here's the city, which we were working on previously, but now we want to make an actual city shape, so we need to lay out. The first step to make the actual city is to lay out roads. And so we're working on the road network generator. But it can't work like the way a normal road network generator works if you read papers on city generation, because they assume a finite city. So we have to be able to be in the middle of the city and just spontaneously generate something. So we're looking at this road network overlay. Like each checkerboard is a road network tile, and each tile can, or chunk, and each chunk can get generated independently of every other chunk, yet they have to all connect seamlessly. So that's what we're working on. Okay, so why did we generate that intersection there? That intersection there, wait, which one? That one there. So that is part of this road, which is road 1-1 vertical. If x equals 1 and y equals 1 and vertical. All right. Let's see if we see it generated at the end. RE. So that's at the, I've already forgotten what it looked like. Number is 6, so the last one is 5. Facing road dist -18. It has one valid intersection at x equals 31. Wait, there's more than one? Oh, no, that's just the squiggle. Oh, we generate this edge multiple times. Yeah, okay. So what was I looking for? That. So that could be 31. Zero, 1, 2, 3, 4, 5. It was the 5th slot, right? Okay, so let's run it again, and now we can see it happen. Side dist is 31. But wait, if side dist is 31, we should be generating the side disks everywhere. Oh, it's maybe this. It's this path. Yeah, okay. This actually just needs to delete everything. Okay, yeah, I don't see false intersections anymore. And the idea here is that on this edge, we just generate some crossings, and it's up to the chunks on either side to decide how those crossings continue. on this one, we generate a facing edge for the buildings to face along here. So the roads have to continue on an unknown distance on this side, but on this side, the roads intersect and might continue. We don't know. It's up for this chunk to decide if these roads continue or not. And then one more thing we might want to do is try to make roads on this edge across here match roads across here. Right now, they're just never going to align, and they have to zigzag to come through, except incredibly rare circumstances. So if you want a nice straight boulevard through, you have to actually add that explicitly in the edge, and we'll worry about that later. So now we want to get back to doing the other strategies for generating these facing roads. We have 3 so far. So we have to do, we've set that up. This doesn't, the actual variants don't match this variant list. But we're doing this one, and we're doing this one in a couple different ways. We're doing this step as part of it. We need to implement this variant. 1 X value from bottom corner, 1 X value from top corner. Cross facing road up and down. Right, okay. So I understand what this is saying. So this is so now we want to put it back to side dist of 2. And we say side dist of 0 equals side dist of 1 equals we need to redo how that works. And that will always be that. That will always be that. Okay. So here we say side dist of z. Z equals 0. If side dist 0 equals 0 or rm then side dist of 0 equals corner side dist 0 of which facing of 0. And the side dist at the far side is whichever side is close. 1. Then side dist transition if absolute of side dist. So can these side dist roads meet on the same thing if it's less than min intersection spacing? Min intersection spacing. Side dist meet. Meet equals, they can meet if they're that. And then the transition happens somewhere along the lots. So we have the number of lots here. So side dist transition equals RR of from 1 to lots minus 1, minus 2. If lots was 2, this will be 1 to 0. That doesn't work. So if lots equals 2, side dist transition equals 1. Why does that not just work? Should it be lots minus 1? The transition, if there are 2 lots, wait, is lots the number of crossings or the number of lots? So number of lots. So the number of crossings is 1 less. The crossings are numbered 0 to lots minus 1 to lots minus 2. So 2 lots, there's 1 crossing. If side dist meet, if they can't meet, then if lots is less than what, 3? The first one is at 0, we stop there. We start again at 1. So yeah, it has to be at least 3. If lots is less than 3, side dist of 0 equals side dist of 1 equals 0. Then there's no place for them to transition, so we disable it. And you know, to disable it, maybe let's have let's bring this back. Side dist. Use side. Then we get down here where we're doing this streak. Okay. Right, okay, so here was where we were. Use side dist equals false. Where did we have the... Right, let's make this high frequency so we can debug it. And then this all only needs to be if use side dist. So then we say if so we've already generated rec 1. Where do we do that? We do that here. So this needs to get moved down, moved up before we generate rec 1. But we don't have lots yet. That's why we were doing it down here. Okay, so this needs to get moved down. After we compute our lots. And so then use side disk can move down to after we do our lots, but before rec. Okay, so we can side disk transition at 1. That should fall out automatically. If they're not going to meet, then we have to use side disk transition. Okay, then Z needs to change. I think before, if j minus 1 equals side dist transition, z equals 1. I guess we can just do z equals so if we're at 0, we want the first one that we generate to have the new one, because we have the old one here. No, we don't have the old one here. Wait, here. We have the old one here. But if j minus 1 equals side transition, side dist transition, and not side meet, let's just do that. If then we replace it with 0, and that creates a gap. Okay, what we're supposed to see is these roads flip from one side to the other. Like here, it's supposed to have flipped. This one shouldn't flip, I don't think, because it didn't generate an intersection here. But obviously, I'm missing okay, first of all, we're not hitting the flip case most of the time. Here's one that should have been the flip case. Okay, let's hit the flip case 100% of the time, if we can. And let's take this out. So that's I believe it's this one. I had a bug. Okay, that one looks like that's the correct implementation. But here, and here's a flip one. So it comes out here, goes down here, flips across. This one goes up here, stops. This one goes here, but we generate a bogus intersection I have to fix. But I think this looks right, actually. Except for the bogus intersections. I can't really explain Eli 5 what you're seeing because people keep asking me to do this every 10 minutes. So, you know, rewind the stream. Okay, so I just wanted to figure out where the wrong intersections were coming from. So make intersection on edge. We should always have an intersection if use side dist is true. We should have 2 at this one. So make intersection on edge. This is only valid if it's not 0. So now we don't have any false intersections. We only have legit intersections. That all looks correct. Now we also have chunk boundaries in here. Since those are on a scale of 1024, we have chunk boundaries on a scale of 256. So let's draw those chunks. Because now we want to make the edges, make sure they don't put roads and intersections on chunk boundaries. And there's no code to guard against that currently. So like that one might be too close to an edge, I don't know. I'm just wondering why that edge continues past. But this is debugging visualization, so it continuing past may just be it may just be something in how I logic this debugging, and it's not actually in the data. So I don't actually see any that overlap the tiles. Very obviously. Here's one, I guess. Right here. It's a little close, although it's probably just barely inside. So, what we want to do is we want to add a function int nearest 256. Oh, actually I can just mask out the bottom bits, can't I? right? That'll do it. And then that's always explicitly perturbed away from the corner. So here's where all the logic is right now. Okay, so the corner side disks are always safe. Simple connections are explicitly generated from negative max facing disk to max facing disk, so this should never approach 256. Multiples are 26. Yeah, so here's the only place where we do this is when the sum of the lot sizes. All right, so we renormalize our lot sizes, and then here, here we've renormalized our lot sizes. So then, if the sum ever falls equals nearest 256 sum, if that is ever too close, how close is too close? I guess 32. Then we need to displace it away. If sum is less than val, then sum needs to get further away. Sum needs to be val minus 32. Okay, so let's put that on a parameter. And safe dist. Oh, I think we actually said the safe dist was 15 in the corner. Yeah, 15. Yeah, we'll allow ourselves to get within 15. So safe dist is 15. So less than safe dist. And the sum has to be val minus safe dist. And to make that work, we have to say lot size of I. So the correction factor here so we moved the sum from sum to val safe minus dist. So we subtract that much. So we have to subtract that. There's no, the fact doesn't actually cover the voxel game stuff. Yeah, below the camera. This is so the safe dist else the sum is going to become val plus safe dist. The update is going to be val plus safe dist minus sum. We're going to add that. So lot size of I plus equals dist lot size of I plus 1 minus equals test. Expected sum. Expected sum equals sum plus lot size. Then we'll actually compute the sum here. So we use the updated lot size. And then we don't need to update sum at all. And then let's break in here and see. Let's trigger it. Okay. So we get here, I is 2, lots is 5, the sum is 359, the expected sum is 514, which is very close to 512. So that would place an intersection at 512, which we don't want. So we compute dist, which is 13. So the idea is we'll add 13. Now we make sure the total is the same. And now when we add sum, instead of getting 514, we get 527, and we're pushed away from it. Expected sum of 266, which is 10 away from 256, so we have to push it away a little further to 271. The same one. Expected sum of 250, so we have to push away from that. Okay, so that looks like that's working. It's hard to tell because it was hard to find any that were bad originally. Like these still look pretty close. But that's actually, this is pretty close, just that's a generated value at 15. So I think that all looks right. So I think we're ready to now do the road network chunk. And we just have to also be careful while doing its internals to push away from the 256 boundaries. So let me check in. So gosh, I don't even know how do we connect these edges and avoid intersections. Well, let's see. If we guarantee that we connect the left side, anything that has an intersection is connected to its corner, to a corner. So we need to guarantee all the corners are connected. But then you also have these stranded ones, the ones that don't have intersections. These ones that don't have intersections have to be explicitly connected. But naively might just try connecting every crossing to start with. So what we could do is we could just pick an arbitrary crossing and connect them with a little dog leg. But that dog leg has to be, if they're too close together, that dog leg creates intersections that are too close together. So we don't want to do that. So we want to actually pick ones that are a little further apart. So it might be like this. So we could start with that and then connect everything else to that. But some things might not be able to connect due to them becoming too close. So the way I solved this in the old one is I just drew a square road sort of like this in the middle and connected everything to it. So I didn't have to worry about them colliding with each other. So we could do something like that just to start with at least. It gives us something to do. So we say we have to generate all the edges, all the corners, actually. So after we generate all the corners, we can generate this. So box of 0, 0, so bottom left is corner 0, 0 dot x1 okay, yeah, we can just do this. It'll always be the corresponding box, the corresponding corner of 0, 1. So that's x0, y1. No, I'm reversing these. That's y0, x1. Okay, so that's that. Oh, these need to be four coordinates. These are points. Y1, x0, y1, so y0, x0. Okay. So those are the four corners that impinge on our box. J of I 0 plus equals corner J of I dot x origin. Minus C dot x origin. So then, so that is the box bounds. And then we have a box that's actually 2 by 2. And the box is going to be The leftmost edge is the greater of the two left points. And let's do it like this. This should be 1, 0. And let's do this in a more sane way. And then this is I should use a point data structure instead of a macro sub2 would be a lot clearer, since I'm only indexing by constants. I probably have a point data structure, I just don't ever use it now. Okay, if the upshot of all that is if we do that and then we contract it by the intersection, min intersection, what was it called? We've done all this. Min intersection spacing. If we offset by that, then you guys I can show you what the heck I've been doing. And it didn't do anything. But I subtracted C origin. What? Normally we say corner origin minus plus that minus C origin. So it's the same thing we did here. Corner origin minus C origin. Takes the x0 plus the x origin minus that origin. The double semicolons cause issues now, but I'll fix it in a second. One of these needs to be min, although I don't know why that would be cause that specific problem. It shouldn't, in fact. we're not initializing y. That's the problem. All right. And I see it drawing lines, but they're in the wrong spot. So I have a bug. Y0 min. Well, let's just check in the debugger instead of guessing. Okay. Y1 101 111. Let's go 0 to 2 0 to 2 111. What? Okay. Why is that not correctly computed? Corner J of I. No, corner 1 of 1. Looks totally legit. Did I not define this data structure to be 2 by 2 by 2? 2 by 2 by 2? Is it getting overwritten somewhere? The fourth value in each of them is wrong. J of I of 0. I, J. What? What? How is it that sub 0 sub 1 is correct, but sub 1 sub 1 is wrong? Corner J of I Y origin looks good. Oh, it's already wrong. Oh, because it's up here. Yeah. See if somebody saw that in chat. Yeah, somebody saw it in chat. Okay. Yeah, so now there's these skinny boxes within each thing. Let's move them in by 2. Actually, by 3. Let's see what it looks like if we move them in by 3. Let's make the boxes not so skinny so we can see it better. Let's move them away from the edge of the safest. I guess x0 equals nearest 256 x0 plus safest. interest. Okay. So now we just need to connect the crossing edges to these things. And make intersections. And we need to add the larger of min intersection spacing and min lot size, whatever it was called. Min lot size. So now we can go over all of our edges, find all the crossings, here's the old code, else. So if oh, right, yeah. So road edge crossing, so if either of these intersections are valid, no. Rec of RFI 0.valid. Do we have a K? No. For K equals 0, K less than 2. If R of K dot valid and rec Ri of K dot X greater than 0 and rec Ri of K dot no. Oh, I guess we have to use side dist. If edge is vertical, then if it's a vertical edge, then the crossing goes horizontally, and the intersection is, we care about the x position of the intersection to determine whether it's in our side or not. Oh, I guess we've already clipped the intersections, so we can just check if it's valid. Okay. So if it's valid, break. So if k is less than 2, we have an intersection already. Consider extending from it. Otherwise, we need to connect up to our thing. So we go if vertical x is e arrow x origin minus c dot x origin. Y equals rec arrow dist from corner. And then x1 is, well, we can't use x0, those are our box. Let's call that bx. Probably should have searched and replaced that. A bit faster. Bx. So down here we can call these x, etc. So x1. If x0 is less than 512, I guess, then we want to extend to bx0. Otherwise, we extend to bx1. Y1 equals why do we do roads this way? I mean, it's yeah, intersections use the center. Oh, because it could extend to either direction. Yeah, yeah. This is clumsy. Yeah, I'm gonna change what the road, how the roads are stored, but let's leave it alone for now. We won't even actually use the real width. We'll just check that. Else, now we do all the same logic, but reversed. And then we say make clipped road. Yeah. Oh no, okay, we do do it that way. Okay, I don't need to add those offsets. That was what I was confused about. It seemed weird that I need to offset. We do just store the center line, so two of x, either x0 and x1 are the same, or y0 and y1 are the same. So I don't do this. So now this one got extended across, this one got extended across. Where we have an intersection, we want to use this code. And we go from E arrow rec J, it's just rec. Facing road dist to 0. I don't actually see them extending to 0, but maybe because they're not far. Yeah, okay, they are extending to 0 like that. And now let's go ahead and have them connect to the center too. But only if they're within the bounds. Okay, so that's, let's just share that code. And we can suppress it. Okay, so then we only add this if y0 is greater than and absolute y0 minus by0 is less than, is greater than min intersection spacing. Absolute 0 minus by1 is greater than min intersection spacing. Then we can do it. Not dist from corner. It's a vertical. Yeah, okay, that is right. And then this becomes x. That was that code we moved down. Okay, so now we're connecting all these things. Some of them don't connect because all these corners don't try to connect to the box, because they need to turn to connect to the box. Here's a stranded point. Not sure what that came from. We didn't make any connection between these two, but we could have made a simple connection, it looks like. So I wonder why we didn't. Do we still have code that disables, that just randomly some of the time we don't make the connection? I think we might want to get rid of that. Because of the way the chunks are turning out, it's really awkward if it doesn't have that. Oh, I can just do this. That was supposed to be RM also anyway. Oh, let's just make this opaque. Let's make it not show through. It's just disturbing. Just disable blind. Now it's too high contrast. No, this one still didn't connect. I wonder why. That is edge 1-1 vertical, which we looked at before. So let's break in that and see what's going on. We get road edge. Use side dist is 1. Okay. We can hit this case. Yep. Okay, so if we hit this case, okay. If we hit this case, we want to fall back to one of the other strategies. Because we could use simple instead. So what we need to do is do this logic earlier. So when do we do this? Okay, this case can only happen if they're unequal. but it requires us to compute the lots first. So we need to move the lot computation up earlier. Which I think is fine, because I think it doesn't depend on... So compute roads crossing this edge. And then compute roads parallel to this edge for buildings to face towards. All right, we have a raid, so let's give a quick view of this. So we are working on an infinite procedural city. So I just have a very simple building generator that has not had much effort put into it, although it does have stairwells in every building has a stairwell and an empty elevator shaft. Here's the empty elevator shaft. But you can see the city does not have any layout to it. And so what we're working on right now is a top-down view of where the roads go. And you can see, to do an infinite procedural city, you have to be able to do sort of random access. So you have to be able to create individual chunks that all connect. And so what you can see here is this box. This is in progress. The box won't be a visible box like this in the end. There's one box per chunk, and there's lots of clever logic. You can kind of see an outline of where the edge of the chunk is, that we're generating roads to match consistently from chunk to chunk and give an interesting layout to the city rather than just like a regular grid. So, what was I working on? Oh, I was wondering why certain things aren't cutting across. I was looking at 1-1 vertical, and I was saying, right, I was saying if it decides it can't do it, and the reason it decides it can't do it is that the two sides are too close. This is not the right logic. It's not that they're unequal. Wait, well, let me check. Okay. The sides meet. The sides meet if they are farther apart than that. Okay. So if they don't meet, and we don't have enough lots, we have to disable this. So that's done here. So if not side disk meet and lots is less than 3, then this will fail. So we shouldn't use it at all. And now the 1-1 edge, I don't remember what it was doing before. What was it doing before? Because now this one's gone. 1, 1 edge. I don't remember what was wrong with the 1, 1 edge before. Was it this? That's the 1, 2 edge. Dang it. Well, let's check if that gets fixed by this code. Yes. Now it draws a connection across here. Doesn't draw the one on the other side, though. That's a bug. That one's not a bug. Those are at slightly different distances, I think. Maybe I should be able to zoom in on this stuff. But that should definitely connect across to that because there's an intersection there, so it obviously means to. Same glitch here. I don't see it horizontally happening though. Looks like horizontally. Well, that one's weird. We'll have to look at that. There's the same vertical missed connection. This one's correct. The intersections don't line up, so it has to do this. This should have a vertical segment extending up to the edge to right here and then continuing up there, I think. That's interesting. That suggests maybe moving this to a line with an edge. Yeah, that probably makes sense to do. But yeah, so we're not drawing one road segment. The last road segment on verticals. But I don't see it happening on horizontals. So yeah, here you can see this is the edge of the between the chunks. And so it's got this parallel road in bits and pieces because they're generated at different Y elevation or different heights up the screen, so they don't line up with each other. Although it's actually not the way you think. It's actually generated a corner here, and this is actually, the edge is actually from here to here, and so it grabs this corner, this coordinate of this corner, and extends the road out that way, and from this corner extends the road out that way, and they don't meet. So why is that road not getting drawn? Is this one? Yeah, okay, here's an example of it horizontally. It looks like these two should line up, and it's not building that last one. So that is, there are exactly 2 lots, but it does meet, and the last one isn't getting generated. I guess I could just break. What's one that's doing this? 1 1 2 1 3 1. So 3, 1 vertical. Side disk transition 2, side disk meet is 0. Side disk equal on both sides. No, it's not. Then this is not the one I think it is. Or it's something going horribly wrong. 3, 0, 1, 2, 3, 1, up. Oh, no, okay. That it is at 2 different y values. Side meet is false. Yeah, okay, that's all correct. So, no, it was supposed to be side meet. It was false. Like, the values in here were correct. So, Z so when J is 3, then it turns to 1, but we hit this case and we don't generate a road. That's correct. Now J is 4. We generate and we generate. That's all correct. So it's got to be in the caller then. Oh, unless this is cleaning it up. It shouldn't be. This is a different one. Yeah, because we got 2 of them after we hit the transition. So this cleans up the last one, but the second to last one was still valid. So it has to be in the caller. So this is 1, 2, 3, 1, but it's on the left side, so it's in 2, 1 chunk. And then the edge is the right edge. It's edge sub 0. So it should be these facing roads. We only do the facing road if there's an intersection. Were we generating? I think we were generating an intersection. Why is J already 4? Why is facing reduce? Okay, there's one that should be 0. One facing reduce should be 0, not 2. Wait, why is my J jumping discontinuously? Oh. Is this not the edge I think it is? E. This is 2, 1. Not 3, 1. Edge of 0 is 3, 1. Am I not on edge? I must not be on edge 0 anymore. Oh, I'm on I of 3. Alright, back in here again. I of 0. Your numeric is 7. I is still 0. J is up to 4. Why is J suddenly at 4? This breaks the K loop, not the J loop. J is 1. Weird. I don't know what was happening there. J is 2. Facing where it is 27. Facing where it is 27. Facing where it is to 0. Facing where it is to negative 15. So that's supposed to create a road there. Should be the vertical path. Facing where it is negative 15 to 0. Step in. Now it's been offset. (1009 to 1024) is all legit. We swap x0 and x1 if necessary. We clip it. We generate it. Oh no, that's the horizontal road. Okay. We want the facing road. This is the facing road. Okay, it's this code that's breaking. J1 side 27. So 4 we get 0 when we don't make anything. So because we only go to -1, the last one, no, the last one doesn't correspond to a road. So yeah, we do go again. Side should be valid. Or vertical. go into make clipped road. And now we're from 780 to 780. That ain't right. So after we've built all the lots, how many lots do we have? 5. And then lot size. Okay. Then we go to here. Aha! We stomped our lot sizes with this logic. All right, well, we call this function twice so we can look at it the second time. Okay, currently 214, so we should never. This one is equals dist instead of plus equals dist. Was something here like this one wasn't getting drawn or something. I think we still have this glitch, but the only thing that's actually glitched here is that it's not drawing a road up to the edge. This one's still missing. No, okay, this is still missing. That's the exact same thing. That's still missing. So that didn't fix it. That plus that we just saw. But let's see if that fixed this math bug. Yes, it did. Now these are all valid again. Facing road dist. Dist from corner does not repeat. So that seems like that fixed that bug. And yet that corner is still not drawing it correctly. So we enable the corner breakpoint, or the chunk breakpoint rather. And look at why the chunk is still failing. Ding, 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 ding. So we were saying it was this logic. J. Oh, it's just side. So 27, 27, we should get a 0. Now we should get a negative. $1,009, $1,009, $780, $995. That all seems legit. It is all legit, and we make a road for it. But somehow that road is disappearing. Or I've got the wrong coordinates. That one's legit. That one's not legit. because it's making an intersection here. So it should definitely have an edge from there to there, which is, oh no, it's this edge 2. It's not edge 0. Edge 0 is this one. This is edge 2. This isn't 3, 1. This is 1, 3. What was 3, 1? So that's, the edge is 1, 3. I think the chunk is 1, 3. Let me look at that again. This chunk should draw an edge here. That is chunk 1, 3. So it's edge 2 now is the bad one. So that's I is 2. Okay. Side is negative 19. Wait, if side is negative 19, we would never draw it. This is on the wrong side. Do I have the wrong chunk? 1, 3. The west edge of 1, 3. 1, 3. That doesn't match. No, okay, this is correct. Facing right is 27, facing right is 42. Edge 2 does match. Why did this fail when I was looking at edge 2 here? I, 0, I, 2. J1, I2, okay, I just screwed up. So we hit a 0, and now we hit 42. So we try to make an edge from 42, 42, 652 to 856. That seems legit. We make an edge. That looks correct. Wait, why am I hitting the short chunk multiple times? I'm very confused. 1, 3, left edge. No, that doesn't correspond at all. It should have been the same distance, not a different distance. 0, 1, 0, 1, 2. It's chunk 0, 2. 1, 2. Not chunk 1, 3. God damn it. I have 2. Side, it's 22. And then we hit the intersection. We get a side of 0. We shouldn't get a side of 0. And now, are we on a different eye? We are on a different eye. Okay, so it's in the edge. So the edge is 1, 2. God damn. I'm bad at arithmetic. So the edge is 0, 2. is 1, 2. Cutting. Okay, we get to here, and allow direct connection, allow tangent connection, allow simple connection is true. All right, so we've got a simple connection. Oh, right, we enabled this to always run. But we fail. As expected, we correctly fail. This doesn't do anything. Use side dist is set. We pick a side dist transition. We don't actually need one because the side dist values are equal. We should side dist meet. It's true. That's what's going wrong here. We need to initialize it to true, not false. It was this one. No, it's still not working. It's still not true. Oh. Why did we hit that? Why did we hit that 3 times? That's very weird. We overrode it here. What we want to do is all right. Potentially generate 2-sided disks matching the corners. So if we do that, we do this. So bool will side disk meet is this. If they won't meet and lots is less than 3, then we can't use that path. Else we can use that path. And why is it contingent on use side dist? Oh, it's not use side dist. So then we always trigger it because we haven't turned this number down yet. And now we can just reuse will side disk meet. And this case can't happen anymore. Maybe. Now that logic at least makes more sense. And it does connect now. This one doesn't connect. but we're getting there. We're getting there. Is this actually min lot size here? We supposedly offset by min lot size. Yeah, I guess it is. Okay, so this is 256, so that's about 100, which is probably what min lot size is set to. One of the ideas there with all that min lot size is that we'll make that biome dependent as well. So like you're in an area that gets large buildings, we bump that size up. You're in an area with small buildings, we keep it a lot smaller. And that way we'll get different sorts of city layouts as we change those values. We could actually even have a biome that just produces a regular grid. Right, like a road every 128 or something like that. So it divides nicely into the thing. Or like a grid that's 128 by 256 or something like that. But it doesn't even have to be an exact multiple. It just if it's not an exact multiple, then that whole avoid being near 256 multiples is trickier to do. Like if it jumps by 77 every time, eventually one of those steps will hit the 256 detector. So like this, all right, we need to actually show the road networks as well. The road network chunks. Okay, now we can see the road network chunks. So when we have a funny shaped lot, or like this funny shaped lot, that's actually a problem. Maybe it's not a problem. The problem is if it crosses between road network chunks. We can't split the lot up well, but actually I think it's fine. Because I think what happens is we put a row of buildings along here, and even though the lot is actually continuous, we can treat each side bounded by the buildings as if that was a solid line where the building is. But most likely we draw a connection between these. That's what we were doing. We were looking at that in the old CMC one yesterday or this morning. I don't remember when. That it had these little connectors. Because we've moved these inwards enough that we guarantee the intersections won't collide. So maybe I actually have to start putting buildings down so that we can see how that gets constrained to match the layout. What is this? Oh, that's a little road sticking out there. Okay. Yeah, so on the sides that don't have intersections, if E of it has no valid intersection, it's only going to ever have one valid one on a given side, on a given chunk. The other, if there is a second one, that's not true. I don't think we pass it through, but I think it actually can have one. If none are valid, then we need to, except aren't we are drawing it somewhere? It's here. This is where we're doing it. This draws from the intersection to 0, but only if there's an intersection. If there's no intersection, whether or not there's an intersection, we do this, which this is drawing the horizontal the crossing segment. Oh, this is only drawing it to the box. If it can't go to the box, then it just needs to go somewhere. I think. This depends which side we're on. X0 equals 0, 32. Yeah, so here's a crossing road that we don't know where it goes yet. So extend them in a little further so they're more visible. Actually, let's just make them a bit fat so they're visible. Some of them line up with the corner roads and therefore have intersections, but they're not. They don't know that they have intersections, apparently. That doesn't actually look quite lined up on the... it does. It is. So we still have to resolve those connecting to something. Let's make this viewer better. So if show roads, then we're going to have a special static int x equals 250, static int y equals 400. And then if ap dot mouse dot left dot is down, then x plus equals ap dot mouse dot delta position dot x. Okay, the scaling is wrong and y is inverted. Float scale equals 1.04. Scale, comma scale. Make these floats. Divided by scale? Maybe? Yep. And then mouse wheel. Delta mouse wheel. Scale log plus equals ap dot mouse dot delta dot mouse wheel. -2. Scale equals pow of 2 to the scale log. Not quite. This needs to be static. This one needs to be static, actually. So let's scale it by 4.0. Let's start at -8. I mean, we just actually just always do this. That's a lot simpler. And then we just want to go a lot further. And test road network So generate. Go ahead and generate this. It might get slow. We might have a lot of our network data. Yeah, it is a little slow. Translation is not working correctly. It's not quite one-to-one. Okay, that's just dropouts due to aliasing. It's off by like a factor of 2. Not off at all. Very confused. Okay, wait, that was a little slow, so let's not generate quite so much data. And then we need to compute scale before that, not after that. Okay. Okay, so now we'll be able to explore more data in more detail, and we can start putting down buildings and be able to zoom in and see how the buildings align more carefully. And let's, if I equals 0 and j equals 0, field color. Make sure we can see where the origin is. Right there. So these two are backwards. And maybe make this 1, 1, 1. Where did we go? 16 to 32, yeah. Yeah, so these two don't quite align, but this position was arbitrarily chosen just to be somewhere inside inside this black box. So we can, before we start connecting everything up, we could adjust this position to align with that, so that that one now can snap straight down onto it. I guess we could just do that. So that's bx, the bx values here. We move them in arbitrarily. Then we can say, over the 4 edges, it'll always be 2 less than numeric minus 1. I think we only ever need to test the extreme ones. So we only actually need to test 2 and numeric minus 2, but we'll just iterate over all of them. If, so the int, the target is the east edge I think we actually do this to j equals numeric minus 2. I think let's just do this for each one by one first and to see what the pattern is. So this is the lowest crossing facing road dist. If the distance between that and the lowest point on the box is less than min intersection, what's it called? Min intersection spacing. Then we can move by0 to top one, like that. Then we can repeat that on the left side. And it's just the same code. So for I equals 0, I less than equal to 2, I plus equals 2 equals edge of I and do that. And then do the same thing for X. Maybe. Missing curly bracket. Did I break this part? Let's check what the current status was. No, okay, these were already like that. So where was the one that I was just talking about that fixing? Was this. I want to see if I could fix that. So that is 2 comma 2. Two comma 2. No, I did not fix it. Unless I'm doing this at the wrong time. No, because I've just computed x, y, b, 0. So that was 2 comma 2. And that was I was expecting it to move bx1. I was expecting this case, I believe. Oh, but the problem is j is only 2. Or, no wait, that's the j. Or numeric is bad? What? Is E bad? E is bad. Why is E bad? Why are edges bad? Because we haven't computed them yet. Doom, 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 doom. Okay, it still didn't get fixed. E of numeric is 4. So E of numeric minus 2 is not greater than 2. This from corner is 520. That's not right. E of rec j plus 1. Rec of j plus 2 is undefined. So wait, why is this from corner 864? Let me look at the map again. 2, 2. Why is this one not the last rec? Why is E error numeric minus 1 not this one? Should be this crossing right here. Which is very close to 1,000. This is chunk 001122. 22. Edge 0, 1, 2, 3. Why can't I type in this? Am I running? Oh, I am running. Oh, because I need to iterate once. Okay. I think I didn't. I was on the wrong one. So 787 is, I think, the one that we expect to hit here. So J is now 4. This from corner 787. BX1 is 764. I know what it is. Okay, if it's within min intersection spacing, or if first of all, it's not facing road dist. It's dist from edge. Maybe that's the only problem. Dist from corner. Not facing road dist. Totally wrong. But also, I think there's a... It can be further than min intersection spacing on one side. We want to still move it. That was what I've figured out. Yeah, it still didn't connect it. Okay, so break, go down to here. Oh, dang it. Break. Go down to here. Wait for I to be 3. Now J is 4. That's correct. Okay. Dist from corner, 787. BX1, 764. The delta between that, 787 minus 764. 23. That is less than min intersection spacing. So we should, in fact, move BX1 from 764 to 787. So that snapped that edge to there, which it did do. It just didn't connect it. So the logic to connect it to the BXs is wrong. Right, okay, so that's because if they happen to exactly match, then we just want to make it. Whoops. I just don't want to do the complicated. I'm doing a second copy of it just because I don't want to deal with the complicated logic. Also, I could debug it and see that it was a different one. BX0 or X0 equals BX1. Okay, that should do it. Yeah, okay, and now you get this big solid line here that we just have adjusted this to match, and to see if that happens anywhere else. Maybe that one? Is it legit to add a connection here without the edge knowing about it? Yes, it is. Okay. So it's getting there. There's still a few ones that don't connect. This one. I'm not sure why this didn't get displaced to match that corner. I mean, to match that crossing. And this one could have got matched to this as well. Both sides of this could have matched to that. Are they being matched to the other side? No. No. So that's BY0 did not get matched on either of those. It's possible we're only matching. So that one's matched to BX0. That's matched to BX1. Maybe we have a bug with the BYs never generating it. It's not happening often enough to be confident. Here's a BX1. Here's a BX1. Yeah, I'm not seeing the BYs trigger, so I might have a typo. Yeah. So it seems like this is right, but this might be wrong. Or this part of it. Oh, I didn't push it all the way up to 24. X0 is BX0 or BX1. Oh, here's a BY0. Or BY1, actually. And here's a BY0. Okay, so what was the one that I was looking at that I was surprised it hadn't made a match? This is the starting screen. This could get moved up to there. Makes sense that it didn't because of the min spacing rule. Because it starts to conflict with this one potentially. This one, it seems like it should have aligned these two. Oh, yeah, my zoom is not centered on the cursor. So it seems like it could have moved this one to match that, but that's not the one I was looking at before. What was the one I was looking at before? Because it was on both sides. Or something. I don't remember exactly. Second black square to the right of the box. So either that one or that one. Well, I don't see anything about either of those. It was a crossing that didn't connect on either side. 4 chunks above the white box. I thought it was a crossing that didn't connect on either side. Oh, this right here. It seems like this and this both could have gotten moved to match this. So that's so annoying. The zoom, when I change the zoom, I get lost because it's not centered. Okay, so it's this one right here. So 1, 2, 3, 4. So it's edge 2, 4. God damn it. I gotta fix the zoom. It's edge 2, 4 though. Let me fix the zoom. So when you scale, let's move X to the center. Maybe something like that. Not positive. You need to disable that. it's not centered on it. If we subtract, no, subtracting just makes it worse, I think. Oh, no, that kind of seems right. All right, let's try zooming on the white box. No. Okay. Maybe that's just entirely the wrong logic for how to do this. I don't really know what the logic is for how to do it. We move. Do we have to negate that? No, I don't think so. We move. Like basically we want to be, oh, we need to do it to where the cursor is, not to where the center is. Mouse dot position dot x. Maybe. Nope. Negated. Okay, I'm gonna have to actually stop and think through what the actual formula is for this. Yeah. How do you do a centered zoom? Okay, if you wanted the zoom to always be centered, the zoom to actually zoom on the center of the screen, you would track the location of the center of the screen at all times. And then the zoom would just automatically zoom relative to that. So we would translate to x plus window size over 2 as our center, and draw everything relative to that center point. But if we translate x, y after scale, do we need to do this before scale? Maybe? Now the movement is wrong, but let's put this back the other way. No. Oh my god, I have no idea how to do this. I've done it before. I just can't think what the logic is for it. You have to negate y. This is not zooming correctly on either x or y. No, it's just doing the totally wrong thing here. No, these need to be divided by scale. But these maybe are times scale? Doesn't really make sense. Okay, first of all, I screwed this up. And I got this one. Okay. Neither X nor Y is right. That's just zooming to there. That's just not even using the mouse position, really. Oh, it is, but only the tiny amount. So multiplying by scale was reducing that effect significantly. That's still zooming in the corner. It's still just not having any effect. Yeah, I divide by scale originally. That was the... I'm just trying to perturb it and figure out what's wrong. Okay, if I zoom from the corner, okay, so one problem is that the Y does need to invert. Both need to invert, apparently. If I'm up here, I'm zooming from the bottom left corner. If I'm up here, I'm zooming from the top left corner. So then I don't need to invert Z to invert Y. But when it was uninverted, it was still doing the same thing. No, okay, it is definitely better the other way. Like this is almost correct. So there's a Y inversion, but just changing to plus and minus doesn't fix it. Of course, because it's absolute position. So you have to do AP dot window dot size dot Y minus. But it's still totally wrong. And X is still totally wrong. I don't know. How do... Audio. No. Incorrect. Whoops. Called odd timer. There we go. All right, here's a program I have that does have this kind of zoom. Okay, zoom factor just by the mouse wheel. So we find what the mouse was over and we adjust to match. Okay, we can make it work that way. Float x over y over. Well, x over is ap.mouse dot delta position dot x over scale is that x time scale? I always forget what's the order of these. Y is over y plus ap.mouse dot delta position dot y. Or scale. This is just going to compute the same thing we were computing. And so now x gets x over minus, not delta position, just position. Pretty sure this is just computing the exact same thing. I tried both translate first and not translate first. Okay, well this goes through the cursor, so it's clearly not right. Now the scrolling will be screwed up, but that's okay. The zoom is still clearly totally wrong on both x and y axes. And this is just computing what I was computing before. But at least there's a systematic rule to it. Okay, if we scale first and then translate, this needs to be either time scale or not at all. I don't remember which. Not at all. Okay. Which means I think we want the other order because we want the actual absolute position. Yeah, that's not any better in terms of the zoom. So I'm pretty sure we want the other way. Does this need to be negated? Aha! Yep, that needs to be negated. The zoom is not correct. Or time scale? What's a time scale? divide by scale. Okay, gosh. Yeah, the problem is I put those translates in backwards, and then I compensate everything else to it and never realized it was backwards. Okay, so now I can zoom in on this particular thing, and so it was up here. This one. So this crossing, the question is why these two didn't get adjusted to match it. So that is 1, 2, 2, 1, 2, 2, 2, 3, 2, 4. So it's the edge is 2, 4. And the neighbor is 1, 4 and 2, 4. The chunks. Let me check that in. So I said it was 1, 4 and 2, 4. So here it's edge 0. Is the edge on the right. It's got 6 intersections. Is that right? One, 2, 1, 1, 1, 2, 1, 3, 1, 4. It's got 1, 0, 1, 2, 3, 4, 5. Yeah, so 6 intersections. So edge 0 has 6 intersections. So edge 0 gets processed here. And it's this top one. It's this one. So J is 4. E of rec of J. Distance from corner is 774. BY1, 753. They are within radius. So we should move BY1. Is the problem that we then move it again? No. Oh, is it this? It is. It's close to 768. We displace it away from 768. But that asks the question, which, yeah, you can see it right there. Why is this crossing there? The crossing should get moved away. Oh, it's not that one. It's this one. Here. Why is this crossing right close to 768? It should have gotten displaced itself. So that is edge 2, 4. Vertical. And it's this code. It's here. So we're on I expected some. So it's eventually going to hit something close to 768. We can't move the 0th one. Oh, no. Okay, right. The expected. These are not in the right units. we're starting at bound 0. So here we start at bound 0. Now, 2 0 2 1 2 2 2 3 2 4. Aha! And now it's connected them. Because now it moved this one away from the 768, the multiple of 256, and having moved it away, it could now match these to it. So it moved this, and now it moved both of those. So there you go. Cleaning up little bits and pieces. We'll still get a few fragmentary things somewhere, probably. A few things that don't connect, we expect. Yeah, like that one. It's just a little too far for this to have gotten pulled down. We could add a rule that allows it to pull it down further, but then it runs the possibility of conflicting with this. So we probably don't want to add such a rule. We instead just want to, you know, maybe connect to there, or we could push this further away and have this go to here and then turn up, would be another possibility. But it could be that the other side constrains it, like on the other side it's matched to it, and then we have one of these on this side, and so we can't move this anymore because we already moved it to match this one. But that's looking good. It's getting there. We have to generate these intersections, and then we have to make choices for how to connect across if we want to connect across. Like we could draw an edge, a road from here to here, if this intersection doesn't collide with those intersections. So basically we could put a grid through each box. We can add grid lines to each box, and we probably make them be existing roads. That road connects down, or these two roads connect up, and do it on each axis. That's probably the next step. But I think we're at 3 hours. That's probably a good stopping point. So if we do that, now we'll have road details everywhere in the box, and we'll just have these things that we need to clean up. The weird shapes, we need to basically connect these. And then any dangling connections, like we saw earlier, these dangling connections have to have something done to them. And that'll be it. That'll be a working road network. Not necessarily the final one. One thing to do is check what happens if we change the parameters, which will be biome driven in the final thing. But we can say, like, what happens if we have a larger thing and 15. What do we get if we do that? Do we get bugs? Do we get just a different pattern? Just everything is larger. Doesn't look like it's buggy. Still need to make connections, obviously. We don't want it to be bigger than 255. That might break. Yeah, you can see that the box at the center is getting tiny. So this is probably about the limit. But we can also go the other way. What if you had tiny lots? It's still about the same as what we were looking at before. Intersection spacing. What if we allow smaller? Well, if we restrict ourselves to smaller roads, so our intersections are smaller, so they can be spaced closer together. We should change the size of this thing to match this. Should follow min lot size, max lot size. It may be, I'm not sure. No, it's not. Min lot size times 2, max lot size times 2. That will get too big, potentially. A equals min lot size times 2, B equals max lot size times 2, and A equals SB, the smaller of A and $200. What did these used to be? 180 to 230. So the smaller of 180, B is the larger of the smaller of these. This might actually be the smaller of those. Do we want it, or do we want it to be maxed? Maybe it's max. If B less than A, A equals 150, B equals 250. I think this is actually smaller. So this is supposed to allow these corners to get smaller. But it only went down to 120, so it's not that much smaller. Yeah, so now they're these little tiny things, and these are taking up much more of the space. Box spacing. Let's do it this way. There's some times 3 somewhere. Yeah, times box spacing. So this will push the box out further. So remember, the box will get filled in with its own grid. So now we get a relatively dense grid with this setting, because then we can have a dense grid inside each box. And here we have the old spacing. So yeah, so we'll get some variety with that. The min intersection spacing is actually just trying to avoid having intersections collide. And so it depends how big a intersection can be, and how big an intersection can be depends on the size of the roads. So the reality is probably that, and so the problem is, because you generate the corners and then the edges, etc., you don't know what, when you're generating the edge, you don't know what content's going to be in the chunk. So, but you're deciding the roads, your roads, but so you know the width of some roads, but you don't know the width of some other roads. So you have to kind of worst case what the intersection might be. But I think when the edge generates an intersection, it's only doing it because it knows both roads. So it knows the size of those roads, so it can actually generate it. And so we can do something smarter for the intersection spacing. Instead of just hard coding some large size, we can actually like avoid colliding intersections based on their actual size. But this gets us started. All right. So yeah, I think I will stop there. 3 hours now, and an hour the morning session. Not an 8-hour day, but a fair amount of programming. So yeah, I'll take any questions before we stop. And maybe what we'll do is instead of getting this finished, maybe we'll start doing it in the world, just so that when people come in and ask what's going on, we can show them the roads in the world. Okay, last call. Check in the code. Checked in the code. All right. Thanks, everybody. See you next time. Have fun. Have a good day. I wonder if I should do STB stuff tomorrow. I kind of want to just keep on the voxels. All right. See ya.